With a vision of providing quality education to students of various strata of the society, the founding stone of Tuljaram Chaturchand College, Baramati, were kept in the year 1962. The college has been formed with the efforts of numerous people.
Our society is a religious minority institute, and we thrive well with the preamble of Siddhir Anekant, means knowledge from all the dimensions.
119 विद्यार्थ्यांना कॉलेज सुरू झालेलं. आज जवळजवळ 12,000 विद्यार्थ्यांवर पोहोचलेलं आहे. हे कॉलेज ग्रामीण भागातलं सगळ्यात मोठं कॉलेज म्हणून आज गणलं जात आहे.
The college is affiliated to Savitribai Phule Pune University.
We are willing to empower the youth to skill and career-oriented educational and vocational programs so that he will be full-fledged for grabbing the opportunities for his career.
The college has well-qualified team of experienced teaching staff who are always ready to help, assist, guide and motivate the students. Regular meetings are conducted to keep a track of the development of the students and to plan new activities for their growth. Providing various streams of education under one roof makes Tuljaram Chaturchand College a renowned academic institution. With such numerous courses being provided in the college, the administrative department continuously and promptly maintains a smooth flow of activities in a well-managed manner. The college focuses on imparting career-oriented quality education at par with global standard. The senior college offers 3 streams: arts, commerce and science. The college offers 22 different courses for graduation as well as post-graduation in various departments like Geography Department, Psychology Department, Yoga Department, Bachelor of Vocation Program of UGC in 2 disciplines: Food Processing and Post-Harvest Technology and Journalism and Mass Communication. The college has well-equipped laboratories where students under the guidance of their professors learn and conduct various experiments. The Electronics Department. In the research arena, the Botany Department had set up their own botanical garden, well-equipped biology labs. IT Department has well-equipped computer lab with Wi-Fi internet facility where students can develop their computer science skills. The classrooms are well designed with projection facilities and the students are encouraged to have better understanding of their subject with friendly interaction with the teachers. The college campus is built with a central library which has a huge setup of numerous books of various streams. Student can access the library and read on various subjects to gain an in-detail knowledge. There is a reading hall adjoined to the library where the students can peacefully study and take note on various topics of their interest. If a student wants to get some additional information on this subject, TC College also provides an internet cafe. The college has a huge auditorium, Jivraj Sabhagriha, with all the modern facilities, where around the year numerous events and functions are conducted for cultural educational growth of the students. Along with academics, The college has given equal importance to physical development of the student by providing innumerable sports activities like volleyball for boys and girls, kabaddi, basketball, boxing for boys and girls. The college has trained and developed some great sports persons who have won remarkable awards on various national and international platforms. The college provides NCC training where the cadets are given basic military training in small arms and parades. The cadets are well trained and given preference over normal candidates during selections. The officers provide good training and discipline education to the students. The NSS activities are conducted by the students like street plays to bring awareness in the society. Plantation, construction of bunds and many others. And for these activities, the college has received various recognition and awards for their contribution towards society. Since 41 years, the college has been organizing a Moropanth elocution and debating competition every year, which is a state-level competition. The college publishes an annual magazine called Anekant to motivate the creative skills of our students by providing a platform where they can publish their poems, articles, and their opinions.
या संस्थेची प्रगती करत असताना आम्ही MBA कॉलेजची नवीन बिल्डिंग बांधली. अनेकांत इंग्लिश मीडियम स्कूल म्हणून नवीन बिल्डिंग बांधून त्या ठिकाणी सुरुवात केली. या ग्रामीण भागामध्ये हे कॉलेज सुरू होत असताना इथल्या मुलींची निश्चितपणे एक चांगल्यापैकी व्यवस्था झाल्याशिवाय राहणार नाही. कारण सहसा मुली बाहेरगावी पाठवायला पालक तयार नसतात. पण हे कॉलेज सुरू झाले म्हणजे त्या मुलींना चांगल्या शिक्षणाचं दालन उपलब्ध करून देण्यासारखं होईल.
स्त्रियांच्या आरोग्यावर शिबिरं आयोजित केली जातात.
The college also fulfills its social responsibility by conducting various events of awareness and confidence building in women. And to build a healthy environment, it also conducts the activity of plantation. The institute has also received various government funds for its welfare and further development.
Our institute is NAC re-accredited with a B grade. Also, we have undergone ISO certification 9001. The college has received the funding for DST Physics program. The institute is recipient of Star College status from DBT.
The college has also got various funds like College with Potential for Excellence and has won many recognition and awards in various fields.
We are seeking that the student should be at the excellence at par, not only in academics but in other activities like sports, competitive career, as well as the vocational skills.
The teaching department over here is very much friendly. We have a library which includes books from all the streams.
We have achieved many prizes of national and state level.
The college has boosted our confidence. The computer science department of a college has well-equipped laboratory.
The teaching staff here is good at transforming student attitude and creating better individuals.
The days are not far ahead that this institute will be a benchmark not only in Maharashtra or India but at the global scenario.
This is the journey of Tuljaram Chaturchand College, where it has enriched and nurtured hidden talent of students from various strata of the society and transformed them into confident and responsible citizens to excel in all walks of life.
Hello everyone and welcome to this international webinar on Innovative Research Trends in Green Electronics and Allied Technology. The Department of Electronics, Tuljaram Chaturchand College, Baramati, in aegis with RUSA, is proud and delighted to hold the webinar of this kind. Well, I am Dr. Aparna Pawar with my colleagues host this event. So, once again, I welcome one and all. Ladies and gentlemen, basically 21st century is known as the era of information technology. But during this pandemic COVID-19 situation, scientific gatherings, workshops and symposia have many restrictions. So, webinar is the most popular remedy on it. The researchers from India and abroad can share their views, ideas in this way. So, without further ado, let us begin the webinar. So, first and foremost, I would like to invite convener of this webinar, Dr. Jagdish Deshpande, Vice Principal and Head of Department of Electronics, to deliver his welcome address.
Good morning, everyone. It is indeed an honor and great privilege for me to extend my warm wishes to all the distinct personalities from all over the world at this glorious moment. On the behalf of Department of Electronics, Tuljaram Chaturchand College of Arts, Science and Commerce, Baramati, I, Dr. Jagdish Deshpande, welcome you all. As we know, we have joined this digital platform for international webinar on innovative research trends in green electronics and allied technology. And we are fortunate to have galaxy of eminent resource persons for this webinar. Dr. A.D. Shaligram from Pune University, Pune. Dr. Abhijit Burgule from South Korea. Mr. Shailesh Lende from USA, and Dr. Shashikant Sudhistap from Siri Pilani, Rajasthan. I convey my heartful gratitude to all the resource persons for accepting our invitation and welcome you all. Moreover, this event would not be possible without support of our principal, Dr. Chandrasekhar Murumkar, who is the chairman of this webinar. He is our supporter, inspiration, and guide. I welcome him also. We are thrilled to receive a tremendous response from various places all over the world. Many professors, researchers, students have joined this webinar.
Thank you, sir. And now I would like to invite our dear principal, who is the chairman of this webinar, to address the gather.
Good morning. It's my pleasure to welcome you all in an international webinar organized by Department of Electronic Science on a very current topic, innovative research trends in green electronics and allied technology. I'm very much happy that this particular timely webinar on this very important issue will definitely give an impetus of a long foresight what's happening in electronics today and what are the expectations of the world at professional level. I'm very much happy that this webinar is going to mesmerized by the eminent scientists all over the world, and definitely their knowledge, their experience and their views and approaches in the field of electronic science will definitely boost us, each and every one, either the participant or other stakeholders, by joining this a very important event. To name few, I must congratulate and welcome Honorable Dr. A.D. Shaligram, Emeritus Professor of Electronic Science from the Savitribai Phule Pune University, India, Professor Abhijit Borgule, Gwangju Institute of Science and Technology, South Korea, Dr. S.S. Sadistrap, Chief Scientist, Control and Automation Group, Head Societal Outreach Group and Central Electronics Engineering Research Institute, Pilani, Rajasthan, and not but least, Mr. S. A. Lende, who is the technology specialist at Travelers Insurance, Hartford, USA. I'm sure that these eminent scientists will definitely throw more and more important limelight on the issues of electronics of today and tomorrow. Dear friends, we do know that electronics is one of the new branch as far as the 21st century is concerned, because the electronic science is being expected to provide a strong support and technical backbone for several new arenas in the areas of research. Obviously, now we are busy with the new softwares, development of the languages, and to support this, yes, indeed, there is an equal pace of race in development of hardware itself. Yes, we do know that the small chips which are prepared in the form of ICs, they are going to revolutionize the world of not only today but tomorrow. Dear friends, this particular electronic science definitely is seen as one of the most valuable component at professional and applied application in the robotics. And I feel that each and every participant must be understanding the importance of robotic science today, not only in India but abroad. Obviously, the robotic science technology, it has entered not only in the research field and application field, but it has entered into the daily consumer level developmental research. Dear friends, ultimately, the development of new components of semiconductors, new forms of semiconductors is a need of time, because ultimately we are going ahead with the nanotechnology for optimization of energy conservation. Obviously, this is sort of a green electrochemistry, what we are expecting today for tomorrow's better perspective. Dear friends, when we talk about the green electrochemistry and green electronics, obviously there are two issues we should not keep aside and ignore. One is obviously a sort of a radiation pollution, and because of that the hazardous effects which are supposed to be impeding the mankind. Yes, we do have a radiation pollution which is very much an issue of concern not only at the national level, but the another important component which is related with this is the e-waste. Dear friends, we do know that when we are talking about the greener and safer earth, the issue of e-waste is a major concern, and this is one of the most important component where all developed countries are working together. Well, this is a radiation pollution and the solid waste in the form of e-waste which is being thrown not only in the soil but is thrown away in the oceans is a major concern for threatening the biodiversity. And because of that, when we are talking about the 21st century with a safer world for coming era of new generations, the question at every level, the question at every step, one should ask that what we are going to provide to the new generation, what safer world we are going to provide to this new generation. And from this point of view, I feel that this is one of the important line of research which has been undertaken almost in last decade, and it is now getting stabilized, and also not only getting stabilized but going ahead in the developmental and application stage, and that is the use of biosensors. Dear friends, now we are facing the post-pandemic corona era. This pandemic era of COVID virus definitely has changed the approach and attitude of the whole world towards the science. And obviously there is a strong demand of the world from the people like you, the people like participants, and the people like ones who have had a great experience in the field of research. Obviously, the biosensors is one of the most potential area of research in electronic science, and I do feel that such a type of application, such a type of use in coming days, in coming years, and by active participation by the participants like you will definitely going to create a new world, a safer world, and definitely a world which will be pollution free in all the respects. From this point of view, I am very much happy that this timely webinar which has been selected by the Department of Electronic Science for this purpose, I must congratulate Dr. Jagdish Deshpande, who is the convener of this webinar, also his colleagues, Dr. Gavde sir, Dr. Yelapalli sir, and the organizing secretary, Dr. Pawar ma'am. They have taken a lot of pains to make this particular webinar to materialize. And I do feel that this particular webinar is going to change the face of area of research in India and to abroad to some extent. So dear friends, let's come together, join the hands to make a pollution-free world, and for this purpose, this new trends in green electronic science is a need, it's a must, and this is going to provide a new way of roadmap for better world, better mankind. Wish you all the best, wish you all the success, stay safe, stay happy. All the best to you. Thank you.
Thank you, sir. And now I would like to invite our eminent resource person, Dr. A.D. Shaigram. And the title of his talk is Design Techniques and Technologies for Green Electronics. So I would like to call upon Miss Priya Rupnava to introduce Dr. A.D. Shaigram.
Good morning all of you and welcome to the first session of international webinar on innovative research trends in green electronics and allied technology. Myself Rupnar Priya and I am here to introduce our first eminent speaker, Dr. Shaligram sir. Dr. Shaligram sir is the CEO of Savitribai Phule Pune University Research Park Foundation and an emeritus professor at the Electronic Science Department and coordinator of Design Innovation Center of Savitribai Phule Pune University. Before the superannuation on 31st January 2020, he worked as professor and head Department of Electronic Science, Director Examination and Evaluation and in charge Director of Educational Multimedia Research Center at Savitribai Phule Pune University. He was the national coordinator for creation of e-content of electronic science subject under NME ICT program of MHRD hosted by InflibNet website. Also, he supervised e-content creation and MOOCs courses development for Swayam portal. He has been Dean for Science and Technology Faculty and Officiating Registrar of Savitribai Phule Pune University. He guided 41 PhD and 20 MPhil students, published more than 31 books, among them 5 are international, and more than 200 research papers are published in reputed journals. He works as industrial consultant to several industries in the field of electronics, embedded systems, instrumentation, automation, and many more. He has been IEEE member of For 20 years, he was chairman IEEE Electron Devices Society, India Council Chapter 2016 to 18, vice chairman IEEE APEDS Bombay Chapter 1999 to 2003, international consultant on digital IC design under Ministry of Science and Technology of Sri Lanka government. He is the founder, chairman of Society for Promotion of Excellence in Electronics discipline, that is SPEED. So now let's listen from his side. Thank you.
Good morning. Today we will be discussing on design techniques and technologies for green electronics. As we are aware, human life has transformed from ancient cave habitats to modern comfort living. And in this process, we have seen that there are daily struggles which have been there in the early caveman's life. They have changed to new kind of tensions of modern life and fights uh, in the magnetic power machine. Electronics technology has evolved extremely rapidly in recent times and reached almost to a point of explosion. It has changed the lifestyle of people, the way they communicate with each other, conduct business, receive entertainment, education, and so on. Today, electronic circuits have evolved to extremely high performance, ultra large scale integrated circuits made of silicon CMOS transistors and have been indispensable key elements of modern human society. There are several technological advancements and technologies including Internet of Things, nanosensors, biometrics, open AI ecosystem, machine learning, autonomous vehicles, drones, augmented and virtual reality and ambient user experiences, robotics and automation, 3D printing, implantable devices and organs on chip, next generation batteries and solar cells, blockchain and cryptocurrencies, cyber security. These have all evolved in recent times and these are further expanding. There is a survey which has been carried out and the survey suggests that these all technologies, they will be governing the human life in the years to come. Say for example, there would be a connected home kind of concept wherein there will be all the appliances in the home, they would be essentially connected to the internet and through the internet they would be accessible to the individuals from anywhere across the world. So it is not necessary that for operating the appliances you should be at home. You should be carrying your mobile device and through the mobile device you can get connected. There are things like artificial intelligence which have already started making inroads, and these artificial intelligence kind of devices, they are essentially providing the humans the experiences what otherwise you would have got through only personal interactions with individuals. We have autonomous cars, we have drones, we have augmented reality, virtual reality, and these have been used in number of domains. Say, for example, in the surgery, for practicing the surgery as well as actually conducting the surgery, or in the service and maintenance of industries, or for the education and training. So there are a number of things of this kind they are being used. We also see that robotics has become part of the industry, various kinds of services, and even at home. So, for example, there is a robot vacuum cleaner. Now, this robot vacuum cleaner, essentially one has to just get started and it goes to every corner of the house and does the cleaning job quite effectively. For the industries, automation has essentially taken a front seat. We have wearable electronics which is on the human body, and this wearable electronics essentially is say covering every aspect of the human. Say for example, the clothing is made of some wearable electronic devices. Even in the shoes there are devices, you can wear them, on your head, on your spectacles, and so on. So, and these through all these devices, you essentially get connected to the rest of the world. We are also experiencing the smart cities, and the smart cities having variety of say facilities, including the transportation, including the power distribution, including the waste management, and so on. We also have things like the electrical vehicles coming up, and the electrical vehicles, they would be probably replacing most of the fossil fuel vehicles, and the charging also in the due course of time is going to be wireless connected charging. Means you don't have to essentially connect it to the charging station, but you just have to park the vehicle and it will get charged. So essentially there is a wireless power transfer. The modern vehicles, they are immediately, in fact, they have been evolving over the years, and they are getting converted into electric driven. Majority of the electrical devices, they are part of the modern vehicles. So for example, there is a dashboard. Instead of steering, you can use a joystick, and using the joystick you can drive the vehicle. So essentially, we see that there are lots of things which are transforming, and these transformations, they essentially give rise to the progress of the human society. Worldwide population is approaching 8 billion people and growing at about 100 million people per year. The superhighways of commerce in industrialized countries are now filled with consumer goods of global society. There is little question that the electronic revolution of the 20th century has impacted almost every aspect of our life. So we are witnessing and we are experiencing that every now and then surrounding us, there are huge amount of electronic devices. And these electronic devices, in fact, they have become so much part of life that we cannot imagine life without their presence. So for example, we have gadgets like the mobile phone, and in fact at one point of time there used to be probably difficult situations of communicating with each other through the trunk calls and such kind of devices. But now we have a couple of mobiles possessed by every individual, and these mobiles, they have become smart. However, at this point we have to also experience the new truth. And the new truth is rapid advances in technology mean that electronic products are becoming obsolete very quickly. So average time of obsolescence, say for a device like a smartphone, is about 6 months to 1 year. And within this 6 months to 1 year, new products hit the market, they become more popular, and people start thinking about like changing the mobile phone. And there are, say, after a year or after a year and a half maximum, the devices are changed, and the older devices, they are either given back because it is a producer's responsibility, or they are just thrown, or they are unutilized. The emergence of solid state electronics has as a ubiquitous feature of an advanced modern society is posing new challenges now, such as the management of electronic waste. Electronic waste is something which is essentially a major problem, major threat, and this threat will remain through the 21st century for sure. As we see that any product, for that matter, including the electronic products, one essentially starts with some material, and the raw material could be extracted from some mine or some such place. Then it will be processed. Then there is a manufacturing done. Products are say released in the market. Then people start using those products. There are a number of products one can have, and then after a certain amount of time, certain amount of usage, these products are thrown in the waste. Throughout human history, the residuals of daily activities have been disposed often in easiest and least expensive manner as possible. As it happens with any waste, we just put it into the dustbin, and this dustbin essentially is emptied, and probably it is said to be the responsibility of the local government, municipal corporation, or any such kind of uh, local government to collect this waste and dispose it off somewhere. Thus, it is ingraining a perception of no value towards the stuff we call waste. And whatever product that goes into the waste, that essentially causes major threats. Especially the electronic waste or e-waste is any broken or unwanted electrical or electronic appliance. It includes computers, entertainment electronics, mobile phones, and other items that have been discarded by their original users. And in fact, we don't realize it because we are just discarding one kind of device. But if you really look at this situation, the photographs which are shown here, say the computers, they are piled up, or the mobiles, they are heaped, and even the other articles, they are seen here. So these essentially, they are causing a major threat. The e-wastes are generated because those electronic equipments that connect with power plug batteries, which have become obsolete due to advancement in technology, change in fashion, style, and status near the end of their useful life. So they have started giving trouble, and probably because of that, you don't want to continue using them. Similarly, increasing purchasing power and standard of living support the purchase of new equipment on a periodic basis. So this also is one of the reasons why basically the older products are discarded and new products are bought. This, coupled with explosive sales in consumer electronics, means that more products are being disposed even if they still work. We just throw them out, and they become electronic waste. Further, if we just see that the electronic waste is a problem, serious problem, because it is not just because it is a waste, but it is essentially there are things which are associated, and this is more hazardous material in the landfill. And this hazardous material, which is part of the electronic gadgets, this causes increasing human health risks. There are various elements which are part of the electronic waste, and these cause the hazard. These include the lead, cadmium, mercury, chromium, plastics through including PVC, brominated fiber retardants, barium, beryllium, toners, phosphor, and additives, various such kind of materials. These essentially result into very harmful thing for the human health. Enormous amount of electronic products are disposed every year, between 50 to 100 million metric tons, posing grave human health threats from unsafe handling of the electronic waste. Most of these discarded products went to landfills or incinerators instead of recycling facilities, resulting in water and air contamination. Hazardous materials in e-waste like lead and mercury can leach out of landfills into groundwater, and incinerating the plastics in electronics emits cancer-causing dioxins and furans. The batteries in electronic products, such as laptop batteries, also contain heavy metals that can leak into the groundwater supplies once the battery erodes. So as such, therefore, there are various health impacts, including the impacts on reproductivity, DNA changes, nervous system, various organs, including brain or liver. So they essentially are affected. The skin of the humans is affected, hormonal system gets affected, and say various diseases like hypertension, cardiovascular and heart diseases, respiratory diseases. These essentially prevail. We see that there is a kind of ecosystem, and this ecosystem, we see that because of various interactions with the environment, the things are not localized, and maybe there is water, say rainwater, and then rainwater runs over and it just takes away various kinds of pollutants along with it, and these essentially finally enter into the sea, and from there they start affecting the entire land area. As such, therefore, electronic waste management is a prolific challenge. There are principles used for managing the electronic waste, and they include the reduce, reuse, recycle, respond, So these 4R principles, they essentially are primarily promoted for the improvement in the e-waste management. Say, for example, when the products are generated and then they are manufactured and used and they are thrown into the waste, from there one can repair and reuse them. One can say remanufacture into the manufacturing, means part of it, whatever is becoming obsolete or whatever is redundant, so that is removed and something else is added to it, and it is made as if it is new. Or it can be recycled, means the materials are extracted and the materials are recycled. Now, in this entire process, it is very important to understand what are the norms which are laid down by the international organizations. So, for example, there is a organization called ROHS, and this ROHS compliance is very much necessary. Especially, it has been formulated by European Union, and this European Union imposes this ROHS compliances. So, ROHS is essentially Reduction of Hazardous Substance Directive. It is implemented first in European Union during 2003, is influencing the design process of OEMs, other electronic manufacturers. ROH has become the de facto standard to encourage the removal of toxic materials from electrical and electronic equipment. The main pillar for a future green electronic industry. It is here basically we are introducing for the first time the word green, green for the electronics. It is not really in color green, but it is basically which is making the environment very conducive. It is we talk about anything which is helping making the environment better is called as a green kind of technology. For the electronics, it is green electronic industry. It is foreseen by sustainable electronics that imply a feedback technological flow of 99.99% reuse of the output products transformed in waste back into the input as raw material. So this is what is basically the trend. Whatever electronic products, electronic devices, electronic circuits, appliances, so these all, they should be essentially recycled or they should be reused for production of new things again. So there has been a global trend. The global trend is worldwide communities, government agencies, or international research programs like Green Program to 2030 made huge concerted efforts to launch new visions in economy and society, including green buildings, green cities, promoting the green transport development, eco labels for logistics, green economy, bioeconomy, new green energy resources, network on bioproducts, green and cost-effective aircraft designs, and not in the last time, smart, green, and integrated electronics. The green electronic products minimize energy use and have less of an impact on the environment than traditional electronics. This could mean less energy used while mining materials and manufacturing the devices. Further challenges can be identified concerning the conservation and recycling of scarce element and reducing the use of toxic materials and solvents in electronic processing and lowering energy usage during fabrication methods. Such green electronic devices need to be fabricated on industrial scale through low energy, low cost methods that involve low non-toxic functional materials or solvents from renewable or biodegradable materials that decomposes to harmless byproducts. Say, for example, there are approaches which are in the manufacturing process in the recent times. One is using printed electronics that decomposes after use. The electronic waste is a huge global problem, and this essentially can be handled by, say, making devices or circuits in this fashion. Now, here we see that this is a flexible electronic circuit where on the flexible substrate, the circuit is printed using conventional printer. In fact, such kind of circuits, they are very much part of the electronic cabling also. So this is a flexible cable, and on that there are these chips mounted, and they form the complete circuit. So we have such kind of technologies which are evolving, and they make use of green materials. The green materials come in many forms. They can range from degradable circuit boards and organic electronics to metals that are infinitely recyclable and reusable. It is not necessary that we should essentially just look at only degradable materials, because degradable is biologically degradable or automatically decomposed. But it is essentially also important to understand that maybe can we recover the material 100% or say almost 99.99% after it becomes obsolete, after it is useless. So thereafter you just recover everything back and put it into new production. In these, organic and inorganic materials can be used both for considered green, depending on the type of material and how it is implemented. Say there are various materials which are said to be favorable materials used in green electronics. They include aluminium, borosilicate glass, iron alloys, graphene, and biomaterials of different kind. Aluminium in the huge sheets form, rolled sheets, here it is seen, and this can be used for variety of purposes. Borosilicate glass with as a substrate, and then on that there are circuits printed. Iron alloys, they are the natural kind of materials, and they can be used not in the conventional pure iron form, because pure iron form essentially has faster rusting. So in the alloy form, like stainless steel, say for example, there can be usage of these. Graphene is a material which is very useful. It is used in display devices, for the printed circuit boards, or even graphene-based transistors. And then these transistors can be used in integrated circuits. That is very much in practice. So we see that this is a graphene sheet, and then there are various kinds of flexible kind of electronic circuits they can be formed. Similarly, one can make use of biomaterials, which inherently are biologically decomposable materials. So these are becoming more useful as electronics become more wearable, stretchable, and integrated with organic substances. So for example, silk is specially used in biosensors and implantable thermoelectric wireless switching applications. In one interesting example, a team from Florida State University placed silk in a vacuum chamber and coated it with gold, creating hybrid fibers of silk with gold. Now, silk is naturally produced by some such kind of uh, insect, and then we get the silk. So, from the silk threads, converting it into a conducting kind of wire by gold coating. This is something what is done by the biomaterials. We talk about nanoelectronics as the emerging technology. Nanoelectronics is actually something which is already now being practiced. So nanotechnologies applied in integrated circuits give new challenges in nanometric scale structures, launching new applications or new components. Therefore, the further solutions require a diversification among nano components so that other devices can be co-integrated with the CMOS circuitry, because these are CMOS circuits where essentially occupying the front seat in the recent times because of their low power consumption. So now these CMOS are integrated along with various other nano devices to allow new functions. An extremely large palette of diversified devices is accomplished by new technologies like silicon non-insulator technology. Uh, this is essentially useful for producing the three-dimensional structures in the integrated circuits. Normally, when we say we have the integrated circuits, very high-scale integrations are possible, VLSIs, ULSIs are possible, but the silicon on insulator essentially applies to the multi-layered electronic circuits, thereby increasing the electronic component density and giving higher and higher levels of intelligence in a small volume. So these essentially they form major backbone of what is called as the radiation hardened circuits, which can be used in variety of environments, including the space environment or radiation rich environment. And from these, one can also go towards micro machine MEMS and sensors. So these are integrated within the chip, in the sense that we have electronic circuits which are normally said to be having decision making capability, but for the purpose of producing the data or getting the data of the environment or outside, one has to integrate some external sensors. Now these sensors are also part of the chips, and we get the chips which are sufficiently intelligent with capabilities of getting sensors integrated together. In addition to that, we have the organic materials. These organic materials, including resins, gums, saccharides, cellulose, gelatin, and peptides, these can be integrated, and these can essentially form various kinds of electronic sensors, as well as signal conditioning or other kinds of electronic circuits. And these essentially they are implantable within the human body, and they are even digestible circuits. So one can essentially look forward for the future electronics, which is essentially very much part of our human operations, including the food and even the digestive system, or for that matter, in variety of human organs, they can be very easily integrated. Say some of the future devices, they include the MOS structure, but it is not MOS as such. It is basically organic thin film transistor. So we see that in the MOS structure, we have the metal oxide and semiconductor. There are source and drain. Here also we have a source and drain, and instead of channel, we get some organic film. Either the channel is replaced by the organic film, or it can be coated with organic film, and thereby these essentially form new kinds of devices. And these new devices, they essentially help in getting more functionality integrated, and thereby we can say that better electronic circuits or switches, they can be formed, and we can get very green kind of technology. In fact, there is a interesting development, and that interesting development is nothing on insulator. So earlier we talked about silicon on insulator technology, but there is a NOI technology. So this again forms a different kind of transistor. The NOI transistor is another candidate to green electronic devices. Basically, there is sub 10 nanometer structure, less than 10 nanometers. We have the dimensions, and there is an undulated polysilicon structure on insulator. This can be manufactured by etching, especially the boundaries of the polysilicon nanoclusters, providing nano undulated films with top of 7 mm and value of 9 mm thickness, 3 mm thickness. So we have these kind of structures, and these structures, they behave like the transistors. So we have seen that in the integrated circuit, where there were logic gates, there were say analog signal conditioning devices formed out of transistors. Now these transistors are getting replaced by new variety of transistors. One is this nothing on insulator, or silicon on insulator, or the organic thin films, or for that matter graphene, or say carbon nanotubes. So such kind of new variety of devices, they are getting introduced, and they are performing different kinds of tasks as otherwise would be performed by the logic gates or MOS transistors. So here we see that there is a complete new outlook that is being given to the functional part of the electronics. But in addition to the functional part of the electronics, there are a lot of things which we realize, that any integrated circuit or any kind of electronic device, that really is not a bare device. It is packaged, and it is encapsulated into something. Now this encapsulation material, it used to be, in the older times, it used to be glass, or it used to be plastic, or it used to be ceramic. So using these different materials, the encapsulations were done. And for that matter, further, after the PCBs were made, where the circuits are connected together, the PCB material by itself is again a problem. We already have seen that the printed electronic components or printed electronic devices, they essentially make use of different kinds of flexible substrates on which we can have the electronic circuits assembled. And these, they would be making the kind of say green electronic devices or green electronic systems. But further on, to make these systems usable by many, they need to be packaged into some housing. There is a packaging, and within the packaging, we will have now various other materials which will be used. Say, for example, when we buy some product, electronic product, we get a box, and that box contains some kind of packaging material, maybe some kind of foam or some kind of say material that is stuffed into it. And that ultimately, we say, when we take out our electronic product out of it, the rest of thing is thrown in the dustbin directly, without any use, without any delay. So this essentially is a major concern, and making that particular thing green is another challenge that one has to really face. So we look at the packaging, we see that now more than ever before, it's time for everyone to take action towards creating biodegradable and sustainable packaging. Electronics companies are no exception. This article, we talk about a variety of things, wherein we talk about particles or other packaging materials which are biodegradable. What happens is essentially we have been using plastic, and the plastic packages, they used to be quite comfortable, quite useful, but their essentially usage has increased as the electronic circuits or electronic appliances, they increased. The global plastic packaging that got increasing, but beyond 2013, there is a major break in the characteristics, and the rate of increase in the usage of plastic for the packaging has increased. Even though there are lots of measures taken globally on banning the plastic, but still the direct use of plastic is banned, but it is basically part of the packaging material, and therefore there is a huge problem it is going to essentially pose. And this particular problem one has to address. So sustainable packaging, one has to really look at alternatives. Say, for example, a non-food agricultural waste plus mycelium based packaging material. So we can essentially use now material like mushroom, and from the mushroom one can draw certain threads, and one can draw certain uh, materials, and they can essentially form, now instead of using the plastics, one can use this alternative material. So this alternative material therefore is one of the solutions which is looked at from the green electronics point of view. Similarly, one can essentially go for some kind of corrugated kind of material which is formed from either say one of these mushroom like say biodegradable products, or maybe even corn or other kind of food items. So one can essentially derive from these, because this is rich in starch and cellulose, and both they can be utilized towards creating material which is useful for the packaging. Say, even from the say waste that we otherwise dispose, so this waste one can essentially recycle, and one can create some kind of packaging material which is not the conventional, say, thermocol or some such kind of foam. So instead of that, one can make use of such kind of packaging materials, and these essentially are biodegradable, so they do not cause harm to the environment, and thereby making the environment green and helping the electronics. The electronics is this, but this is external material, and this external material essentially is maintaining the greenness of the electronics. We also look at, say, various products that we buy. When we buy the product, basically this is showing a kind of earphone that is bought, and this earphone is coming to you in a box. So if this box is biodegradable, then naturally after getting this particular thing intact, the earphones intact, we can essentially make use of them. But at the same time, when this is thrown in the waste, this doesn't cause harm to the society. So this is probably something what I wanted to communicate, starting from the problem of electronic waste. Uh, the solution is looking at alternative materials, looking at many functional materials included in the functional electronic chips, electronic devices, and forming good integrated circuits rather than having harmful materials into the circuits and then causing harm to the society. It is essentially the green electronics that is going to make our life much better, much improved. And with looking at the increasing use of electronic gadgets and devices and the explosion that is taking place, in fact, it is being said that in the years to come, we will be surrounded with huge amount of electronics, and this is basically all pervasive. So pervasive electronics, it is said. So we will even not know that there exists some electronics, or will not notice for that matter. Like we are not noticing that there is a air surrounding us. So there will be electronics surrounding us. There will be various kinds of devices, gadgets, and these all they need to be green. And when they are essentially like that, then we say that we will be uh, living in the sustainable world. So let us get ready to make sustainable progress with this new transformation by understanding the importance of greenness, by looking at various kinds of aspects related to the materials and various new design transformations. Thank you.
Again, good afternoon, all of you. The green electronics is an emerging area of research nowadays. Respected Dr. Edi Shaligram sir has enlightened us in this webinar session with his wise words on design techniques and technologies for green electronics. Thank you so much, sir, for sharing your valuable time with us. Thank you.
Good afternoon, everyone. Now we have Dr. Abhijit Borgule among us, and his topic is artificial intelligence for smart electronic devices. Let me introduce him first. Dr. Abhijit Borgule, working in Gwangju Institute of Science and Technology, Gwangju, South Korea. He has completed his Master of Computer Engineering from Chennai National University. His research interest in AI, machine learning, deep learning, etc. Now, I welcome again Dr. Abhijit Borgule to deliver his talk.
Hello everyone, my name is Abhijit Borgule and I am from Gwangju Institute of Science and Technology. Before we begin our presentation, first I would like to thank this organizing committee for giving me opportunity to present this work. And also I would like to thank this college for arranging such nice events for their students. I hope you all are doing well in this pandemic situation. So in this presentation, we are going to study about artificial intelligence for smart electronics devices. In this presentation, we will learn about what is artificial intelligence and smart electronics devices and their use of all those applications in several sectors. Before we begin, first let me introduce myself. My name is Abhijit Borgule and I'm currently Research Fellow at Gwangju Institute of Science and Technology. I came to Korea in 2013 and I did my Master of Engineering in Chonnam National University. My current research areas are artificial intelligence, machine learning, and deep learning. So this is our campus. So we call it GIST because it's a short form of this Gwangju Institute of Science and Technology. GIST is a technological institute and one of the top 3 institutes among the Korea. First is KAIST, which is and second is the Postech Pohang Institute of Technology and this Gwangju Institute of Science and Technology. So this is the third ranking institute. So this is the government funded institute such as something like what we have IIT. It is central government controlled. It is so this one also centrally controlled by its government. And we have lots of other departments which they work on their own research field. So if you would like to know more about our institute, you can visit www.gist.ac.kr. And here I am currently recording it. This is our department, computer engineering department. Yes. So before we begin, I would like to share the overall contents of my presentation. First, I will show the overview of artificial intelligence. Second, I will talk about what is artificial intelligence and their 2 basic components. In that, I will also talk about history of AI, how the artificial intelligence is evolved and how it is changing. Second is I will also talk about their applications of artificial intelligence in several areas. One is video surveillance, autonomous vehicles, weather forecasting, healthcare systems, industry automation, and aerospace program. Also, I will talk about use of artificial intelligence in electronic devices. So in that section, we will make our own artificial intelligence system in edge devices, and that I'm going to present in upcoming slide. So what are the hardware and softwares required in order to make our own artificial intelligence program? Second, I will talk about the data collection and augmentation in this section. And then I will talk about data labeling techniques and also the architectures of deep learning model. Then we will look at how the training models codes are and testing models codes are. So let's begin with the presentation. Here is the artificial intelligence, and the artificial intelligence consists of 2 main parts: machine learning and deep learning. Machine learning is nothing but statistical methodologies, and it has lots of other statistical theories and other statistical models. So all those models has been used in order to form deep learning architectures and also artificial intelligence algorithms. So artificial intelligence is a big umbrella which has covered all of these methodologies and all those techniques are used in artificial intelligence are derived from machine learning and deep learning techniques. So so in this figure we can see that we have some tasks that we have to automate, and then in order to do that we build the layers of artificial neural network, which is deep neural network. And those deep neural network we can stack we can stack its layers, and execute all those operations such as training and testing to learn about training and testing technology, and also the two basic components of artificial intelligence. So what is artificial intelligence exactly? It is because in this area we have to let machine behaves like a human. So in simply way, a machine that emulates human brain, some functionality of brain, not all functionality but some functionalities of brain we can implement in the machine so it behaves like a human brain. So for that, mostly models are using artificial neural network. So if you know some of the biology in human brain, we have very tiny millions, billions of neural network in our brain, in our body as well. So each neuron communicates with our other neuron. So that is the neuron structure, because each neuron has their own receptor, dendrites, and all those biological structure. By observing that biological structure, scientists have made a digital form of artificial neural network, which is exactly a linear model, but non, because our brain is much more advanced. So but this is a completely linear model. So by observing our brain neurons, they made this artificial neural network. So if you search about artificial neural network on the Google, you will find more theories about it, and you can look at its history, how they have implemented and improved this artificial neural network. So by combining multiple neural networks to each other, we can form multiple neural network, and we can derive its multiple variants out of those stacks of layers. So yeah, so let's begin with the two basic components that I already talked about: training and testing. Artificial neural network stands on these two main components. These are the basic components of artificial intelligence. In the training phase, suppose this is artificial neural network, means suppose it is uh, just before going to this example, let's look at the example of a baby, a newborn baby, and when it grows to become adult. In that phase of life, that person looks and perceive lots of information by feelings, by other emotions, by their eyes, by ears, and uh, all those inputs from our body. That person learns most of the thing by itself. So that is called the training. For example, in our life we have seen cats, we have seen strawberries. That's why I know those are strawberries and those are cats. Also we have seen bicycles, we have seen vehicles, we have seen other things, because we have seen them in our past, so we can predict it now. So what we have seen it, that is our training. But human brain is much faster than neural network, because it has lots of neuron, and we cannot achieve that by simple neural network, this digital neural network, because we can mimic some of the functionality of brain, but not exactly, because we have our own thinking power that neural network cannot achieve it. But if you look at the example of Sophia, that if you go to Google and search about Sophia, you will find lots of interesting video that it talks with the human, and it's completely AI based robot. So let's get back to this training. So it is the same stack of neurons, and you first train with all those label the data, and after training the label data, you compute the loss function, and then from that loss you update its weights. And this process repeat continues until those loss of this function reaches to the convergence. When it reaches its convergence, we can use those weights to test this model how it is behaving. But this time we don't give any label as a cat. So in this time we just give the image of the cat. So this neural network should be able to propose a label that is cat, or it may predict anything, because it's depend upon how we train this network and how we observe this network. So this is the history of AI. In this history, AI is not new, because AI was already there in 1950. A guy called Alan Turing, he introduced the first machine learning neural network model. But that momentum somehow slipped off, because though at that time those models were not capable of solving real world problems, and it wasn't that mature enough to solve those problems. Even if we that time we didn't that time those guys didn't had much funding to continue that research, so they somehow stopped that research. And that boom again started in 2010s, when some of the researcher around the globe, they proposed AlexNet and some other advanced machine learning models, and everybody started using it. Because when you look at the history of our computer, we had really old computer which had not much computation power. But if you look at our smartphone, these days smartphones are really high computation. They have really high computation than what we had in 90s. So now the computers also, they are significantly improved, and their computation is really really improved to the next level. So you can use those computers to perform the artificial intelligence algorithms into that. So let's begin with some of the applications of video surveillance. Let me change my video that is showing here. So first, begin with video surveillance. Video surveillance is a critical area where we have lots of cameras around the city, and observing all those cameras require lots of people, and that is not feasible solution. For example, consider a scenario where an employee of 100 people are in one room which has lots of cameras of city, and something happens in one of the camera here, that on this camera something happens, then how we can know that what is happened there? So in order to observe that, we need artificial intelligence to look into those video streams and observe those video streams based on our model. So in that, by doing so, we can do object detection, abnormal activity, fire detection, accidents, crime detection, all those serious application we can target here. This is one of my favorite area, because I personally work on video surveillance, and I'm going to show some of on my own results in this presentation. Next application is autonomous vehicle. And this is really great application, because we just tell the car that we have to go there, and the car takes you there. with the help of artificial intelligence algorithms. So there are lots of sensor installed in this kind of car, and they perceive the information all together and feed it to the machine learning algorithm, and they decide what to do based on the sensory input. So this is one of the trending research these days, and many companies have achieved a really significant performance in this kind of research. Next is weather forecasting. This is also one of the great example of artificial intelligence, because in this forecasting, we observe the data of 10 years or 20 years of from past, and we can predict future forecasting based by observing that 20 years of data. So this is really good research for lots of people who have to deal with weather forecasting in their daily life. Next application is healthcare system. In healthcare system, it is one of the great application in drug discovery. I will present this in upcoming slide. So by using all those data that we had of all those diseases, we can predict upcoming diseases based on what we have the current data of disease. And there is, because these days we are interacting with nature a lot than before, so that's why we have this kind of corona pandemic these days. So in order to avoid that, there are some models the scientists are working on to predict what will be the next upcoming pandemic. So if we know this early, we can treat and we can get ready to face this kind of pandemic before even it starts. So this is one of the good research also. And also we can use artificial intelligence for patients care and diagnostics of many diseases. It's one of the great research area also. Next is industrial automation, where a human has to, where in this research, where human has to just stay outside of those machines, and those machines will do their job by itself by observing its sensory input. Next is aerospace programs. If you have recently heard the news of Mars Perseverance lander, this is the first lander who used artificial intelligence technology to guide its during the landing, to guide its best safest to find its best safest position on the land by just taking some aerial pictures from before landing. So I think this is also going to be a new era for the artificial intelligence to work on, because we human eye is like our we perceive lots of things from the eyes. So same thing, a camera is also mimicked, means a camera is also inspired by the human eye. So what we see in the camera, we can have that ability to the future robots to see what we see in our brain. The same functionality we can adapt in near future. So this is one of the great research area. Next is, okay, so let me briefly explain the applications of all those artificial intelligence in video surveillance. So if you look at this video stream, all the people they are walking on the street. So I think it's some kind of shopping area where there is no other cars. It's not a road or something, but some shopping area. So this is a really crowded situation, and we have to identify each of its movement. So human perception do not work in this way, because our human cognitive has ability to focus on only one uh, point at the same time. We cannot focus on some other point. We cannot divide that stream of that what we are perceiving from the current scene. So for that we need computer. So by doing object detection, we can have this kind of results. We can have this kind of results, and then with all those results we can look at each of individual and their observe their behavior, and by observing their behavior we can predict what that person is going to do next. So that is a type of research that many video surveillance scientists are working on. And each individual here in this video, there may be some other crime can happen any part of this video. So somehow we need that kind of attention in this kind of stream. So how this architecture is they are performing all those frames is they take each frame from the input stream, and they take each sequence of frame from those videos, and then they process it during in this architecture, and then they result this kind of detection on each object. So that is called object detection, but it's just object detection. There is no currently other algorithms are attached, but with those results we can do lots of other uh, application with the help of artificial intelligence. So this is one example of artificial intelligence in video surveillance. Next interesting application is when we have this kind of scenario where lots of cars in the highway and suddenly two cars they collide with each other. So in that kind of event, many accidents can happen, and to report it, nearest security teams they need this kind of indication. So in this example, you can see this box turns yellow, indicating that there is some abnormal activities happening. Such kind of events we can trigger, and we can inform nearest security teams such as police and other government officials about this kind of scenarios. There are lots of application we can do with this. By we can identify a car is hitting some other person, and there is an accident happened. So we can trigger those kinds of events in a camera and see how those uh, uh, cars are cars are flowing in the traffic, and we can monitor them. Also, there is another application is that we can monitor the traffic at that particular square, and we can make an intelligent system that can help us to control the traffic in particular area. So another interesting application is autonomous vehicles, and in this application we can tell the car to drive by itself. So in this example, you can see this. This is from Waymo. The Waymo has a car which can drive automatically without driver. So all those operations are performed by artificial intelligence algorithms, and all the inputs are coming from in this kind of vehicle, or that there are several sensors on in the car, and what they do is like they perceive all those informations, how many cars are around, how many pedestrians are around, and after receiving all those information, it can drive by itself. So this is one interesting example of artificial intelligence, and let's see this. So this is our lab's autonomous vehicle project, but due to some technical issue, I cannot show its video. So this is the how work. We set up the lidar and some cameras, also the GPS and radar information, and gather all the information in the computer situated in this car, and then process all those information all together to decide how to drive on the road. So next, in the industrial automation, artificial intelligence is also applied. In industrial automation, we take the sensor input and locate the object position, where to pick it and where to keep it by looking at its appearance. So, for example, there is a robot who has a job to pick some specific object on the conveyor belt. Then it looks for that specific object based on its appearance and what it received the command to do the specific task. So this is one. For that, they use some object localization research to locate the object in 3D world, and then pick that object based on its position, based on its appearance. And after picking the object, we can put that object in a specific rack. So there are some robots, they pick this kind of objects based on visual information of the object. So next also is weather forecasting, that by looking at the pattern of the hurricane, we can predict its most likely position and in the future, and its strength based on its data. So for that, we need lots of training data from history and from maybe 20 years, 30 years of data, and then we can have some ability to predict. So this can save a lot of catastrophic events, and it is also good research topic to forecast the weather. So in this research, they use autoregressive models, which means we analyze the time series data to predict the next most probable outcome. So this is one research is very interesting. Next is the healthcare system. In healthcare system, one of the recent article is published in the Nature Communication that scientists are able to identify the patterns of cardiac diagnostics. So by looking at the ECG interpretations, we can diagnose the cardiac arrest. So this is really good research for life saving, because many people have died because of this kind of cardiac arrest. So yeah, healthcare has several other applications, such as nowadays there is one research trend happening in corona, that by observing each of countries' corona number of patients, and the pattern, they can predict in which area the corona may spread. So this is one good example of artificial intelligence in healthcare system. Next, I personally have more interest in aerospace program and its their application, because this time, if you might have heard the news of Mars 2020 rover lander named Perseverance. It is landed a week back, and first time they used vision-based techniques to locate the position of terrain and plane area, to guide that rocket in the plane area to avoid catastrophic damages to that rover. So they use really advanced machine learning algorithm into that because the latency of communicating with this lander and the rover, it takes 20 minutes ping. So we cannot handle it real time. So we need really accurate and perfect algorithms for that, to have that control in a fully automatic environment. So you can have a thought that you can think in that there are some devices that you cannot communicate with, so they should reach to their destination by themselves. Then you can have your own way of thinking how we can use artificial intelligence to reach up to reach into this kind of situations. So next is why this artificial intelligence is nowadays is accessible, available in many many devices. Because if you look at the if you look at the all these devices these days, they are really high in computation, and they can perform lots of computation on device. So we don't need to have any server or big giant computer for that specific application. So in this talk, we are going to focus on many edge devices that we can make them uh, we can make them to adapt the artificial intelligence algorithm. So these are the edge computers are there, means we can have our private computer for small scale units and small IT businesses. But okay, that is there, we can utilize them to we can utilize them to do our machine learning stuffs. And these are the data centers that mainly it is for government sector and many large academic enterprises that they use it for their machine learning algorithms. Uh, so let's see what are the edge devices hardware. So recently, these two hardwares has been proposed by, this is the Intel neural compute sticks. Means we can integrate a neural network machine algorithm model into this to perform the artificial intelligence task in this kind of USB-C devices. Next is a Jetson Nano. This is from the NVIDIA, where NVIDIA is the GPU makers. They have lots of series of multiple GPUs, but this is their one Jetson Nano for researchers and enthusiasts. If they want to make their own product, they can use this kind of boards to check how their artificial algorithms are working. And yes, so why it is that much easy now? Because nowadays the current processors, they are capable of inferencing all those deep learning models into that small chip. So these days it is very easy to run many deep learning algorithms into small chips. So let's see how we can make our own devices by using simple Jetson Nano. So we will talk about this in upcoming slide. So the hardware, let's look at the hardware specifications of the Jetson Nano. So Jetson Nano has a GPU 128 core Maxwell with the 472 G flops, and CPU is 4 core with the 4 core and 1.43 gigahertz, which is not that bad. We can integrate any machine learning model into this. Second is it has 4 GB of memory, so it is pretty fast. If we because there are not so many algorithms are running. If it is specifically we can design artificial intelligence algorithm, we can For that purpose, it is very fast. Second is the storage is 16 GB. So that means it is you holding Ubuntu operating system to run all those deep learning frameworks into that. Second is video. It is also capable of running 4K video, and encoding and decoding techniques are available in that processor. A camera also has a 24-pin MIPI CSI2, which we can connect 2 or 3 cameras. Maybe I think this has 2 camera support for this Jetson Nano. Second is it can also connect to the HDMI display, and it has USB-C 3.0 support and PCIe and some of the GPIO such as 13 GPIO, I2C, and SPI protocols. So what are the softwares and frameworks that required to run the machine learning algorithms and to test them? So the Caffe, TensorFlow, PyTorch, these are the popular machine learning frameworks. But there are also Keras, Theano, and Chainer. These are also MXNet and Microsoft CNTK. These are also machine learning libraries that you can use. So the benefit of these libraries is that you don't need to make any source code from the scratch. All those models, all those architectures, all those their source codes are available there. You just have to call them and execute them. And I'm going to present one of the simple classification code in this slide. I will try my best to make it simple, but you can, if you want to know about more, if you want to know more about that, you can just directly visit the PyTorch or TensorFlow site, and you will find the easiest source code there. So let's talk about how the training works. So training on GPU computer or any cloud server which requires large data set, and it can train up to some hours and weeks. It does forward backward all the time, and it computes the weights. So this is how the training works in the GPU machine. Similarly, the testing works in little different manner, because it can work on any edge device or compute stick or computer. We don't need to have server for testing. So training, we train our model into a giant server, and we can use a small computer to test those models without needing any high computation. So for training, we sample the batches of input, but in testing, we just give only one sample at a time. It can process that sample in millisecond of time, and second, it just only does forward pass. That means only inference operations are there. And it uses compressed weight, because now the quantization techniques are there. So by quantizing the architecture, we can make it the size of architecture very less. So this can be useful in many edge devices application. So why we need edge devices instead of cloud-based inference server? Cloud-based inference servers are powerful. They are scalable, and they have unlimited storage, but they require high power for their operations. Second, in order to communicate with them, we need high-speed internet, and also it can suffer with high latency. And if we are sending our data, video streams over internet, then again it raises the privacy concern. And it is not portable, but and it is also high in cost. So but in edge devices, it is different. Edge devices, it means, and Jetson Nano is an edge device, and we can put some machine learning algorithm into that and test it out how it works. But in order to make that machine learning algorithm model, so we can train that model in any big computer, and later we can move it there, and we can test its accuracy. So here's the benefits of limited in the edge device. We have the limited computation power because edge device is small. As I talked to you, it just we just have 4 GB of RAM and some less size of GPU. Second, it has limited storage. Again, it takes very less power. You can just pair of batteries are enough to run those devices. Second is we don't need to have any internet connection, so there is no latency problem. And all the data is kept local, so it does on device processing, and it can be it can do this kind of thing in very low cost, and it is portable. You can carry in your pocket and you can have machine learning algorithm with you all the time. So let's build one real life example. So given that we have this Jetson Nano, and we have a camera, we put this in front of our car, and we can identify which object it is. So when we are driving, we can, this is just simple example of object detection algorithm, but I'm going to talk just more general objects in our usual life. So we can make this kind of thing by just a camera is here taking the input, doing some processing here and telling, oh, it's a vehicle. So this kind of operations we can do on this kind of device. We just need to this is the edge device, so we need to just power with the battery and it works. We don't need to have any strong GPU or something. You can purchase this kind of device maybe just for experiment. It's very cheap. It's not that much expensive. Let's see how we can do that. So let's target the basic object detection problem. In this problem, we have the Cipher-10 dataset. Cipher-10 dataset contains all those 10 classes: truck, sheep, horse, frog, dog, deer, cat, and so on. So all those images are given. So we have to somehow train our machine learning model, because it is one of the component from the artificial intelligence, because training and testing, that's what we should do. We have to train something and do testing. So for training, we need to have some data, because nowadays many models are data hungry. They need lots of data, because if the architecture like the ResNet, VGG16, VGG51, VGG50, yes, they need lots of data, because their architecture is so much deep, because they have lots of maybe millions neural networks in one architecture. So in order to train, they require lots of data. So in order to have that data, we cannot make and label all those images. It requires huge amount of time. So some of the agencies like a Kaggle and some of the dataset services are there that they freely make this data for everyone, any researcher among the globe to use that. So this is just one simple data set which we can use data augmentation techniques to make it expand a single image into 20 times more in different pattern. So this is just data augmentation technique. I will explain you about this. So in data augmentation technique, we have a simple parrot image. Then we can do some operation on that parrot image to vertical flip or horizontal flip. We can crop it, with zoom in, zoom out. We can change its elasticity, and we can change its color, sharpen it, brighten, because these are the conditions that we have in our general life. So we have to tell the neural network, okay, these are the possible situations could happen with any object. There could be more than that, but this is just very simple. Just it has lots of illumination, like this kind of thing. It has lots of light because it's sharpened. It is brightened. Sometimes it do not have that brightness, but it can be also inward. So all those, considering all those possibilities, we need to expand the data. So we can take that data to train all those neural network architectures. So Here is the simple training. So we gather the data in batch, and for each batch we pass all that data to come to through this architecture. This is VG16 architectures, which has 5 pooling layers and 3 dense layers. Dense layers means they are fully connected layer. Each neuron is connected to all neuron. Yeah, and in the output we have 10 output neurons. Means any neural network applications, we need to have at least what the output we want, because that is deterministic output. Because what we want, for example, in the case of 10 classes information, we need to have 10 outputs, because one of the output will have highest probability that this particular image belong to that class. So whatever the number of your class is the number of your output in the neural network. So we are using that number of output here is a 10, and we pass all those images. And we, when we pass the batch, we also pass the batch, what the batch and how many samples in the batch multiplied by number of classes, and we pass all those labels all together here. And we pass it through this loss function. So loss function has loss function does is it computes the error between predicted label and actual label. For example, the actual label, we are passing the image of apple. So the predicted label is, for example, some other label which is maybe some different class number. Then we can compute the error between that difference. So that is our loss. So based on that, we change entire weights. So again we do the same process. So when the loss is dropping at some point, when the graph it will dropping, and some point it will reach close to 0, in that case we can assure that the network somehow trained, and in order, so we can verify it by giving the test data at the same time. So here is the training algorithm. So for now I will be hiding my video, because I want to show you that entire frame. So here is the input, and then we have layers of transformations on that input, such as we apply linear, sigmoid, 10H, and all those activation functions in those layers. And then the prediction comes, because this is all convolution operations, and all the operations are happening here. And then we get to the prediction. So the prediction is what we have given input, and what is the prediction is came. Then we compare that prediction with the ground truth prediction, with the ground truth, and then we have the loss function to do that, to compute the loss. And then loss goes to that gradient descent optimizer. This gradient descent optimizer updates the weights based on this loss information, and again this process continues. So for loss function, we can use categorical binary cross entropy loss for object classification, and there are binary cross entropy. There are lots of loss functions nowadays, and people are working on to improve the loss function, because loss function is the during the training there are lots of research is happening, class imbalance, and many steps are there. So many scientists are working to improve the loss function, but some of them are still working to improve the internal architecture. So you can have more interest of doing this kind of research. So this is the one thing I'm going to talk is the learning rate of the. If you look at the learning rate here, so learning rate is one of the important parameter in this kind of training. Suppose if I explain something to you in a very fast way, then you will not understand. But if I explain in a slow rate, then you will understand. The same way, this is the same thing. Have ability of a neural network. When you train a network with a higher learning rate, it will not understand what is happening there. What are the inputs are there, and it will perform very bad on the test data set. So we need to have somehow control or optimal point of on that learning rate. So if we control the learning rate somehow to the not the lowest one and not the highest one, somehow optimal one, because the lowest learning rate means it will take so much amount of time to learn something. So it is something like if I start to explain you something in very slow rate, then it will take that much of time to you to understand. So same way it is happening here as well. So this is how our brain works. When we watch something that is really fast, that we cannot understand, but if we watch something that is really slow, then we can understand what is happening there. So this the same functionality has this kind of neural network architectures. So there are some other to avoid the overfitting problems in the loss curve. There are lots of other dropout and other operations such as batch normalization, momentum also there. And there's a popular algorithm called ADAM and stochastic gradient descent. So you can use one of those algorithms to in here to do network training. So this is just a simple flow chart of the training. Let's move on to testing. So in the phase of, for example, we used that Jetson Nano, and we have already trained this architecture and put into the Jetson Nano, as I talked to you about, and we give the input of cat, then it should have the highest probability at the end for that cat, because we want, for example, in this case we have 2 outputs, so or maybe it could be 10 output. So one of the output will be the higher based because the input is a cat. So if it is not happening, that means there is something wrong with the architecture, or maybe the image quality is less. So these are the possible scenarios could happen in this kind of application. So it is not always perfect because we cannot rely on this kind of, but they are almost 90 to 96% accurate. So nowadays many researchers have achieved really good accuracy on this kind of application. So I'm going to explain you how we can build this in the code, and I'm going to explain how the testing models codes and training model codes work. So let me present this. So here what we do is we have this torch, as I talked to you about. This picture quality is very less, so I'm sorry about it. So the torch is the library for deep learning and other machine learning method techniques. You can use this torch to run the many algorithms here. So in this case, you see the C410 is loading all those 10 classes here. So if you just call this, if you install the Python and then you install the torch, you can run this code to load the data. That is data, you can load all those 10 classes data. And after that, you can create the neural network architecture. So torch is mainly a work in inheritance. So when you call this NN modules, it loads all these internal functions there. So as I talked to you about, you don't need to have the convolutional neural network to build by yourself. You can just call this function and neural network will be there. Then you can apply this pooling operation that is called the max pool. And then again you apply the convolutional operation, then you apply the fully connected layer. So these are 3 fully connected layers, that is dense layer. So in this case, this architecture is very small, and you can also after this, in the forward pass, you pass the input, apply the ReLU pool, and then like this, these functions are being called here, and then you have this features computed here. So this is how the network works. So in this network, the output is a 10 because we want to have 10 classes. So this 10 is belong to the number of output in our classes. You can customize these classes as per your requirement. For example, you want to design something that the person is holding, for example, has kept a mask. In this kind of case, you can just make 1 or 0. It just make two output. If the person has wore a mask, you can say 1. If the person has not mask on their face, you can make it 0. For that we need binary cross entropy in order to, but the main thing is that we need to generate lots of images which a person wore a mask or not. So you can choose the application as per your requirement. And then next you can here is the simple example of training, where you load the input and then you have the labels. That means label data. And then you set the optimizer grade 0. That means 0. We can make the parameter 0 because this is required in the torch. And then you pass the input architecture and you get the output, 10 outputs here. And this criterion is the loss function. Here you have the output and you have the labels, so you compute the loss here. And then you say the optimizer to do that back propagation using this loss. And then you do this procedure again and again, and you have some multiple epochs. So when this epoch is happening, you can observe the loss, how the loss is changing over the time. So within 10 epochs, 10 to 20 epochs, you can observe that this loss was 2.272. Then it is reduced to 1.30. So that means you can conclude that it is training. But sometimes we don't need. Sometimes we need more epochs. Maybe sometimes you need maybe some hours of training if your architecture is really big. So during the test time, you can use one of those images. So right now this image is a little blurry that even human cannot identify it. But still, this kind of architecture is well trained. It can still able to find it what is in this kind of images. So we just pass this image to the and get the output. And here is very simple. We just get the max. What is the output that which class score has the highest probability, and because we use a max among the 10 number of inputs. So you can see that it says cat, sheep, car, or plane. So this I don't know, it's a cat or something because I also cannot able to identify it, but this is a ship and it is identified as a ship. Even human cannot distinguish this, but so it has ability to distinguish even in blurry images. So this is the beauty of artificial intelligence. It has really great accuracy. That's why in the last 10 years it is really improved, and it is being improved again and again. So thanks for listening. And yeah, I'm if you have any questions, you can get my email address from your teachers, and you can send me email, and I will be happy to respond to you there. Thank you for listening.
Thank you, sir. It was indeed a very interesting and provoking talk. Thank you very much. Since morning, we have been listening to scholarly talks by an eminent speakers. All are really interesting, inspiring, and thought-provoking talks. With that, we come to close at the end of the first day of the webinar. Tomorrow, our session will begin at 11:30 am, and YouTube link of the same will be provided in the Telegram group. Feedback link also provided in the tomorrow's session. Feedback link is also provided at the end of tomorrow's session. So see you all tomorrow. Till then, take care. Bye bye.